In this video, we're going to give you a quick introduction to e-ink displays, what they are, how they work, and the different types of displays you can get. E-ink displays were invented at MIT in the late 90s, but didn't become popular until the late 2000s with the launch of the Amazon Kindle. E-ink displays were designed to mimic the appearance of ink on paper, and unlike traditional displays that emit light, they were designed to reflect light just like paper does. This makes them easy to read even in direct sunlight and gives a wide viewing angle. Due to the way the technology works, e-ink displays consume zero power whilst not updating and can more or less hold their image indefinitely. We've since moved on from just e-readers, and today you can find e-ink displays in shelf labels, packaging, signage and more. But let's take a closer look at what e-ink actually is. The e-ink fabric is made of lots of tiny microcapsules filled with electrically charged particles of different colours suspended in a viscous oil. By applying an electric field across these capsules, we can change the orientation of the colours inside. In its simplest form, e-ink can place black particles at the top of the capsule to absorb light, or white particles at the top to reflect light. When the charge is removed, the particles stay suspended in the same position due to the oil in the capsule. Since the original e-ink technology, there's been a variety of different technologies that all follow this same principle, but allow for different types of displays, such as Spectra, which introduced the ability for 3-colour displays, Carta, which allowed for higher DPI displays due to its small particle size, and the newly introduced Advanced Colour e-paper, which introduces cyan, magenta, yellow and white particles which can be blended to show up to 4096 colours. You may notice here that we have more types of particles than electric charges, and in order for this to work, these technologies use light-charged particles but in different sizes. This ensures the particles will move at different speeds through the oil, and along with some complicated electrical field manipulation, allows the particles to be arranged in different ways. This, however, is a lengthy process, and as such it'll be very difficult to create a multicoloured display that can update in less than several seconds or more. For this reason, multicoloured displays are aimed at signage and shelf labels that don't update very often, rather than displays that respond to user input. When it comes to updating e-ink displays, a waveform is applied across the top and bottom electrodes to control how the particles need to move based on display technology, display size, and most importantly the ambient temperature, as this affects the viscosity of the oil. The top electrode is given a common voltage called VCOM, and the bottom electrode is given a positive or negative voltage. The VCOM value is calibrated during the manufacture of the display and is different for every e-ink panel. A common misconception is that e-ink displays can only update slowly, and this really only depends on the specific display you're using. Some displays can update very quickly and also with the ability to perform partial updates. This is when the display is updated immediately without flicking between black and white states first, which e-ink displays usually do. The trade-off, however, is that it's possible to leave a ghosted image of the previous display, and it's also not possible to partially update to a shade of grey. As a result, it's recommended that partial updates only be performed when needed and full updates are performed when possible to remove the ghosting. There are two types of e-ink displays you can get: displays with built-in controllers and displays that require an external controller. Internally controlled displays are generally quite simple and usually only require a 3.3 volt power supply with a serial interface and some external components to support the built-in power converters that generate the different voltages required. These displays have the correct VCOM already set once they leave the factory, and they usually have the update waveforms built in as well. But it's possible that these might have to be externally loaded by the host microprocessor, depending on the display you're using. Externally controlled displays will require a controller, power converter, memory to store the waveforms in, and will need to have the VCOM value set correctly. Whilst externally controlled displays are more complex to set up, they're generally a lot more versatile in their capabilities, update quicker, and support higher screen sizes and resolutions. So if you're thinking of using a display in your upcoming project, remember to consider using a low-power e-ink display with excellent contrast. And if you decide to go down the e-ink route, remember to ask yourself if you need a black and white display, grayscale display or coloured display. Do you want a simple internally controlled display, or would you like the benefits of an externally controlled one? And do you want a display that updates quickly or performs partial updates, or will a slow updating display suffice? Thanks for watching this video. I hope you got a decent understanding of the e-ink technology. If you liked the video, then be sure to leave a like, subscribe for more content, and I look forward to seeing you in the next one.